Now, as I mentioned previously, we have two guests with us today from South Dakota State University. We have Jessica Garcia Fritz with us today. Jessica is a full-time assistant professor in the Department of Architecture at SDSU, where she teaches design studio, architectural history, and a building workshop. Jessica earned her Bachelor of Arts in Architecture and a Master's degree in Architecture from the University of Minnesota School of Architecture. Jessica will be discussing how RhinoCAM is used in her building workshop for the Gothic Vault project. Welcome, Jessica. I'm glad you was able to make it. Jessica Garcia Fritz from South Dakota State University, everyone. Jessica?
Well, thank you, Don, and thanks to MecSoft for inviting both Frank and I as representatives for the Department of Architecture at South Dakota State University. I want to mention a few things about our department and the school, the university, because we are relatively new. We are a brand new architecture department. We started in 2010, and we are the first accredited architecture school in the state of South Dakota. So South Dakota was the last state in the U.S. to have an architecture program, and as of spring 2016, we are officially NAB accredited. So this is a fairly big accomplishment for us, and that's our MARC program. So with that, with the birth of the department, we've been able to explore the use of technologies, and we stand by this creed of learning through making. And so as we start this up, we've been able to be fairly autonomous in the way that we approach thinking through architecture. So as I said, one of our main creeds is learning through making. And we do this in all aspects of our curriculum, and we really encourage the students to make physical models. We've worked through public works projects as full-scale mock-ups, as well as actual design build projects. So within the department, we sort of have these three tenets that we work through. One is working through practice, so we work with local firms. One of the second tenets is a public works sort of a sub-department where we work with various communities throughout South Dakota, and most of these communities are small towns, usually population 3,000. We've worked with towns like Mulber, South Dakota, Huron, South Dakota, as well as Webster. And really the third tenet is the exploration of architecture through the building arts. And this is something that we've established fairly well through the building shops, which you'll see this project as we move on. It's a building shop project. I believe Frank's is also a part of that curriculum. Really what the buildings arts are, it's an exploration of the technologies that make buildings. And it's not necessarily a purely technical approach. This is an approach that looks at the incorporation of the humanities as well. So many of us as professors, if we take on a building shop course, we're looking at the combination of thinking through history and theory through these technologies. Typically, for the shops that I teach, they're rooted in Gothic vaulting, which will be seen, and typically I'm exploring systems through history. As Don mentioned, I teach studios as well as a large part of the architectural history courses, which have been explored through construction history. But nonetheless, these building shops are a core course within the curriculum. So the building shops are offered, there's typically, students will take 3 throughout their time as an undergraduate student and a graduate student. Sometimes students will take more, but they take at least 3 from 3rd year on into their 6th year. So we are a 4+2 program, meaning that we've got 4 years of undergraduate school and then 2 for the Masters of Architecture. And most of these building shops, when we teach them as faculty members, there's 7 of us, so each of us have had an opportunity to teach one. When we teach them, we're looking at an incredibly focused study. So these building shops are 2 credit courses. They're taught for 2 hours. once per week. And most of the approaches taken in the course is that we're looking primarily at collaborative work. So students are working as teams. Some of the types of shops that have been offered are ones in which a professor and their students will explore a tool, a system, a method, or a material. So for example, one of the instructors had looked at the ruled surface walls of Eladio d'Este. Another instructor's looked at lamella arches. Others have looked at bent plywood. And in this particular course that I'm sharing, we're looking at vaulting methods. And we're not looking specifically at how the vaults were made historically. We're looking at how we can use historic methods, explore those through lecture, discussion, and then apply contemporary digital practices to the making of Gothic vaults. Can you move on to the next slide, Dawn? So in this slide, you're seeing of course, the interface for Rhino, and there's really three parts to this. In the large interface, you're seeing the tas de charge, and in the upper right-hand corner is the full Gothic vault that is made through Rhino. So overall, in this course, we are looking primarily at making two types of vaults. We've explored the principles, the tools, and technologies for making this particular Gothic vault, but we've also looked at Catalan vaults as well as funicular vaults. But in this particular project, we are using the Gothic vault as a catalyst for exploring digital tools because it's a component system. So it's incredibly efficient in the way, first of all, structurally, but also in the way that it can be modeled in Rhino. So in this particular example, I give the students the dimensions for this vault, and the idea is that they digitally model all the individual components. We select the best digital model, and then we move it into a physically assembly. So a little bit about that digital modeling. Well, first of all, we're diverging a little bit from historic methods because we're not using stereotomy, which is the art of cutting solids. So typically in the Middle Ages, masons would carve individual components very accurately using a variety of tools. And what we're looking at is we're looking to make the molds that make the components rather than the other way around. So in this particular case, this is a vault that spans 2 feet by 2 feet. It's a typical star vault, meaning that it has diagonal, transverse, longitudinal ribs. And then it's also, it uses the Tierra Cerrone ribs, which you're seeing there in that purple color. Everything is color-coded. All the components are color-coded. But in this particular system, the main building component, the main unit, it's referred to as a voussoir, which is a French term. So all the individual colors are the individual voussoirs. And one of the things that the students that I have to check for is that the students have a tendency to want to build this in Rhino as a full surface, as something that is just one solid vault. But that would not help us through the fabrication of this particular piece. So what they end up having to do is think about cutting and joining these individual components together. So they start off with a simple line drawing of the plan and elevation, and then they build up the individual voussoirs and bring them together into this particular model. So where the arrow is, that's pointing to the tas de charge. And the tas de charge is the gathering of all of these individual voussoirs into the base of the vault. And if we're looking at a Gothic cathedral, the tas de charge is really the transition point between the individual voussoirs, which within the rib, it carries the load to the column, which of course carries that load to the ground. So there are hundreds of feet in the air, typically over 100 feet within the air. So students, they'll draw the plan and elevation. They model the individual components. This is something, again, that I have to check for. And all of these components, I asked them to color code them so that I can see that they are made as individual solids. So the yellow that you see there is the same voussoir that is modeled in orange. It's the same as the blue voussoirs in the diagonal rib. And they must use the cross-section of each of those components in order to sweep it across these various lines. Ultimately, what we have then is we have a finished digital model that everyone completes, and we choose the one that is modeled the best, and we move forward with that particular model. So then everyone breaks into teams, typically of 3 to 4 people, and they are responsible for making the molds for casting the model. So we're going to look at the TAS discharge, which is that large piece that you're seeing within the interface of Rhino right there, because it is the most complicated piece. It's really the collection of all of these components coming together. So next slide. And this is the TAS discharge within its molds. As we're moving on through the process, this was a team of 4 students, and this was a mold that was completed in 2015, the fall semester of 2015. And the making of the mold is, it's fairly straightforward. In fact, students find this to be one of the easiest parts because, again, it's within the digital realm, so there is no gravity, and it's very easy to make these incredibly precise and accurate components. So TAS discharge, it's off to the left, and at this point in time, the students are forced to think about what type of materials they are going to use in order to first cast the TAS discharge and to make the molds that make these components. And we usually decide on what the material is going to be. In this particular semester, we looked at hydrocal as a casting material. We've used cement in the past. We've used Quickcrete, but this particular semester, we're looking at the use of hydrocal. And most of the students are using a fairly common material as a stock material in order to make the mold, and that is rigid blue foam. We don't have access to many materials here in Brookings, South Dakota, so most of the time the students will either order the materials off Amazon, or we do have a Lowe's, and so we find that just getting material off the stock shelf is fairly easy for us. So we do make a lot of blue foam models as well as molds. So in this particular case, we stress the idea of making a mold and not formwork. The main idea with a mold is that it can be used over and over and over again, whereas formwork is used as a one-time component. So in this particular case, the students who are working on this team, they have to be able to make 4 of these components to serve as the base for the 4 corners of the vaults. So they ended up using blue foam as their medium, and they essentially cut the TAS discharge into the foam using the Boolean tool. So they were essentially just removing the material in that particular way. And they also had to figure out a way to be able to open this in order to remove that particular component once it had been cast. And so it was a very straightforward process for them. Where they run into issues is in the next slide, when they're actually using RhinoCAM. So let's move on to the next slide. And here's where we're establishing the drill bits, the type of path that is going to be used. I know Dawn is going to explain this process a little more clearly and specifically later on in the webinar. But the main idea here is that the students are having to choreograph the tool path in order to make it work for this particular mold. And this is where we can get into these great discussions of how a material will begin to alter the way that we make a digital model. And this is probably the most frustrating moment for students, not necessarily because they're using RhinoCAM. Actually, RhinoCAM is incredibly helpful for us to think through this process. It's the frustration comes in the lack of perhaps accuracy and precision that's just a result naturally of materials coming together within the physical world. So one of the concepts that we're teaching students in the use of this particular tool is that the use of digital fabrication in making the 3D model and then bringing it into the material world is something that results from the CNC machine, which has a very specific way of working. And this is no different than the way that the master masons had worked in the Middle Ages or even into the Renaissance and the Enlightenment period. That their particular tools had essentially carved a path through these voussoirs, through these components, and what we had was a resulting component that was at least a part of a system that was structural, but it was also something that was it was forced because of the particular tools that were used. And the CNC router that we use is no different than that particular idea. So the idea here is to create a toolpath, of course, in order to cut this on the CNC router. And what the students were finding as they were mocking up and sort of choreographing these different toolpaths is that they would see moments where the collet would plunge into the material, or the bit wasn't long enough, or the bit wasn't able to move into a corner as easily as they thought it was. And it's not necessarily that is a terrible thing. It's just that they had to learn to work with that it wasn't going to be something that was going to precisely cut out the model that they were looking for in Rhino. So they had to incorporate that as part of the process. And in fact, as Frank and I were mocking this up once again, we found the liberties that this team had taken when they were making this particular model. And there were several discrepancies. One was that they actually cut off the base in order to make the base a little more flat. So as this is a class, of course, that's ever evolving, so in this next iteration that will be completed this fall, in fall 2017, what I'm looking at doing is to talk a little bit more about the choreography of the tool and to make that a part of the class, of the outcomes. This is something that we've discussed a little bit, but not as clearly in these past couple of semesters that we've tried this. So these are the tool paths, and then finally, so we can move on to the next slide. The students must take all of the components that they fabricate and bring it into an assembly system. So you're seeing one of our students, Emily, there. She's deep in thought. And this is, again, one of those other moments in which there's a little bit of frustration as they're trying to bring all of these individual components that were fabricated separately into the system. And this is another point where we stop and we look and we say, okay, what are the discrepancies? Where are the issues that we're running? What are the issues that we're running into? Really, in this class, we know that there are going to be failures, and we expect that. The idea is that with those failures, we're able to talk about them, discuss them, and then figure out a way to get around them. This is really something that we try to work out through various iterations, and sometimes we can't get to all those iterations, but in this particular case, we had to actually refabricate a couple of these pieces because of the fitting issue. When you look at the image that is in the middle top, that is showing how we're actually bringing the system together without a sealant for the time. So the idea is that these components should come out of the process as perfect components that can be dry stacked into a system. We do apply a construction sealant after the fact in order to keep it intact for the rest of the year. But when we first assemble this vault, everything is dry stacked without any type of adhesive. And so we try to take the centering away to see if it is something that can stand up. This is a purely compressive system, meaning that there is no tension in it, so everything is essentially relying on these heavy components falling into place. But nonetheless, we do see a lot of failures at this point, and we do end up having to go back to the fabrication system. So what RhinoCAM is teaching us in this particular project is that we're starting to learn that we have to be able to incorporate the tool of RhinoCAM as well as the CNC machine. We have a techno system, we have a techno machine. We have to incorporate that into the way that we think about cutting these molds. And at first, the students, they felt a deep frustration because they couldn't get the tool to do what they wanted it to do. They wanted to have this perfect cut component that was exactly the way that it was, the way it worked within the digital model. And unfortunately, that's just not the way that these types of systems work. So in the end, they had to go back into RhinoCAM, or they had to go back to the fabrication or even the digital model in order to allow to be flexible and allow that system to work into the way that they were thinking. At the same time, while communicating with the other groups in order to make this component system work together. So ultimately, RhinoCAM is something that we've thought through as a certain type of choreography, and we hope to push the machine further on into these semesters as we start to document these failures and learn from them and adjust our assembly and fabrication methods accordingly. And I think that's it for the Gothic vaulting project.
Next, we're going to have a demonstration of MecSoft's educational products. Hopefully y'all can see my screen. What we have here is one side of Jessica's Taj mold. This is side A of the mold, and we're going to go ahead and go through the process of creating the toolpaths for this mold so you can see how easy it is to do in RhinoCAM. So I've got Rhino 5.0 installed, and up here we have RhinoCAM 2017 loaded, so we'll drop that menu down, and it lists the modules that you can get in RhinoCAM. You have the milling module, the turning module, you have a nest module, and an art module, and we'll be going over those a little bit more in just a moment. For now, we're going to load the mill module, and the machining browser displays on the left in RhinoCAM, and it's very easy to create toolpaths in RhinoCAM, and we'll show you how to do it. Now down here, just a moment, I want to mention that here is Frank's tool library displayed in the bottom from the Tools tab. So what we're going to do, it's a very simple process. You just start from the left and work your way to the right, and we'll start on the Program tab. We'll see that we have our machine, and we'll set that to 3-axis. So any surface that has a contour or a draft like this part, we need to set it to 3-axis. Then for our post, we have it selected to Frank's Techno. Now we also support over 200 other post processors that are already configured, and we also have a built-in post-process generator if you want to edit these posts, or if you want to create a new post. All the tools are there available to you. And we'll set the post-to-file extension to NC for now, and you can set it to any extension that your controller expects to see. If you don't see your extension here, you can always create one. Next, we have the setup option. By default, when you open a new part in RhinoCAM, you have a setup that is aligned with the world origin in Rhino. And if you can turn that machine setup triad on and off, as you can see it there. So we have a setup already defined, and it's at the bottom right corner of the part, and that's fine. We can leave it there for now. Now for stock, we'll go ahead and create a box stock, and if you pick the copy model bounding box, it tells you the length, width, and height minimum dimensions you need to cut this part. So we're assuming that the stock has been cut out to this size, and it's set up on the machine in the bottom left corner. So we'll pick OK there. So now we have our machine, we have our post, we have our stock, we have our setup. Now for material, you can set a material here, which is basically for visual purposes. Later, when you create your tools, you can define a specific material and select from a library of feeds and speeds based on your material selection and the tool selection. So we'll leave the material set there. Now, we don't need to work zero since we got our machine origin already set to the bottom left right corner of the part. So let's go ahead and create a roughing operation. We'll select 3-axis. We'll select horizontal roughing. Now, in roughing, if you don't select anything to contain a geometry to contain it, it will cut all of the stock away from the part, and that's what we want. So we want all the stock on the top of the part to be removed, so we don't need to select anything here. For the tool, we're going to use Frank's A8 tool, which is a 3/4 inch flat end mill. Feeds and speeds, we'll load those from the tool. For the clearance plane, we'll just leave that set to automatic. For the cut parameters, we'll leave 25 thousandths of stock on the part. So this is Z level roughing, so it's going to cut it out in levels. So every level, it's going to stay away from the part by 25 thousandths. So, and we're also going to set the cut pattern. You can set the cut pattern for different types of conditions within the part, cavities or faces. We'll leave it set to offset for both. And for a step over, we'll go ahead and set that, say, to 40% step over. This is about 16 inches square part. So we want to have a little bit larger step over, so we don't need to cut it so fine in the roughing operation. So for the step down, the cut levels tab, we'll set that to 50% of the tool diameter, and let's go ahead and generate that. Now this is calculating the stock in relation to the part, and it's slicing it in levels and determining the tool paths to remove the excess material from the stock down to the part. If anyone has any questions, please feel free to enter them in the chat window, and we'll get to them at the last 10 minutes of the program. So we have our horizontal roughing operation created. Let's take a look at it. So we see that it's sliced it down in levels, and you can take a look at each level here and work your way down and just do a visual see at each one of the levels here. So let's go ahead and simulate this. We'll go to the Simulate tab, we'll select the operation, and then we'll pick Play. And you can turn the toolpath off so you can see it, the stock material being removed. That's what the roughing operation looks like when it's completed. So let's go ahead and do a finishing operation. We'll go back to the Program tab. We'll go ahead and go to 3-axis, and we'll do a parallel finishing operation. Again, we're going to finish right down to all of the visible part, so we don't need to contain it by selecting any geometry. So we'll leave that. For the tool, we'll go ahead and select a 1/4 inch ball mill that we have added to the library. Feeds and speeds, we'll load those from the tool, same clearance plane. For the cut parameters, we're going to cut right down to the part. So this is a finishing operation, so we'll leave the stock set to 0. And for the step over, let's go a little bit finer than that. Let's say 20% step over, and you can adjust this step over to get the as fine a finish on the part that you want. For our demonstration purposes, we'll use 20%. For the rest of these tabs, if you want to contain it, if you wanted to contain it in the Z-axis, only cut between 2 certain levels, you can do that here. Entry and exit and advanced, we'll leave those set, and let's generate. So that was pretty quick. Let's go ahead and look at the parallel finishing operation. So you see that it's sliced in parallel planes across the part at a 20% of the tool step over. So let's go ahead and simulate this. We can turn the toolpath off so you can see it. So there's our finishing operation of side A of the tiles to charge mold. Now we've got a second half of this mold, which is a mirror of this, which is the top half of the mold. So we'll probably use the same toolpaths. So what you can do in RhinoCAM is that instead of recreating all those toolpaths, we can just save them to a knowledge base. So let's go back to the Program tab. We'll save these to a knowledge base. And we have one set up here for SDSU. We'll just overwrite that. So now what we'll do is we'll go to the next part, get it displayed on my screen, and I hope you can see that. So this is the opposite side of the tiles to charge mold, and we want to use the same operations. So to save a lot of time, we're just going to go straight in and load our knowledge base. So now you see we have our horizontal roughing operation and our parallel finishing operation that we saved to our knowledge base. Now, because neither one of these operations need to select any geometry, we can just select the setup, right-click, and regenerate. So it will regenerate both of the operations and display them in just a moment. Now this has a little bit more material, roughing material to remove, so it might take a moment too longer than the first one. So we've got our roughing operation completed. So there's our material removal in Z levels of the part, and we also have our finishing operation. And these are the exact same operations and parameters that we used on the opposite side of the mold and saved to our knowledge base. So let's go ahead and simulate both of those. So there's our roughing operation, and here is our finishing operation. Again, if you have any questions, feel free to enter them in the chat window and we'll get to them at the end of the program. So we got our finishing operation. There we go. These sides of the part A and part B of these molds are ready to send to the CNC machine. And when you're ready to post them, just go to the Program tab or select the setup or either one of the operations and right-click and post. And here is the G-code for the Techno.